Hey, this is Mr. Ward, and this is a video key for Algebra Do Now 25.3. It says B and D only because this Do Now is being reused from last week's A block, day 3, and y'all didn't get a day 3, so here we go. So apparently you went on a very expensive hat shopping spree, and you, after doing that, you chose to go to the bargain hat store. You bought 2 pointy hats and 3 propeller beanies, spending a total of $43. But your friend bought 3 pointy hats and 2 propeller beanies and spent $47. What are the unknowns here? Well, I've told you how many hats. I've told you the total amount each of you have paid, but I haven't told you how much each type of hat costs. So cost per pointy hat, okay, and cost per propeller beanie. Okay, I'm going to call that X. It is completely arbitrary which one I choose to be X and Y. I'm just choosing the one that came first. Okay, and there's a pointy hat old school style there. And now we need to figure out, so if we came up with the pointy hats and the propeller beanies as being the unknowns, that's good. We need to come up with equations. So let's go back and look at our information. We know you spent 43 and your friend spent 47, so those are totals. We have 2 pointy hats and 3 propeller beanies. Now, this is not 2 rates. However, the unknowns are rates. So you do have 2 rates. So this is a good candidate. Both of these are good candidates for standard form because you have the X being the rate and Y being the other rate for pointy hat costs and propeller beanie costs. And you have a total. And if you multiply 2 pointy hats times the cost of a pointy hat, that gets you a total cost for pointy hats for your purchase. And that works for all the other numbers of hats. So let's go ahead and use standard form. Okay, so we know our 2 totals are 43 and 47. And I'm going to set it up using the AX plus BY structure. And so an AX plus BY structure of a standard form. I already know that C is either 43 or 47, depending on whether it's you or your friend. And now it was you who got 2 and 3. Your friend got 3 and 2. So for you, 2 pointy hats and 3 propeller beanies, and your friend got 3 pointy hats and 2 propeller beanies. I'm going to label these equations you, your friend. Okay. Let's see now. Oh, and here's actual footage of a propeller beanie being used for human flight. Cool. All right, so if you came up with those 2 equations, that works quite well. 2x plus 3y equals 43, and that's you, and 3x plus 2y equals 47. That's your friend. And let's go to Desmos. So 2x plus 3y equals 43, and 3x plus 2y equals 47. And let's see what that gets us. Well, it gets us off the screen, so we got to zoom over. And there it is. There is our intersection point. The red line is your shopping spree, and the blue line is your friend's shopping spree, and of course the bargain place. And so we've got a point at 11, 7. Okay, so that tells us that it costs, let's actually label that. We can do this. It costs $11 per pointy hat and $7 per propeller beanie. Okay, and that's good because you can afford more propeller beanies that way, and that'll allow you to fly. So that's awesome. Okay, so let's go back in here, and that is our solution. The solution to this system is this, because it makes all parts of the system true. And that is what makes something a solution. Now, there's a neat thing we can do that borrows a little page from ye old book of uh, common denominators. So we've done some experiments where we added and subtracted equations, but if we added or subtracted these equations from each other, you're going to not eliminate any variables. But we can manipulate these equations a little bit by scaling them. So we could triple the equation for your shopping spree, and you get 6x plus 9y equals 129 there. So that's just all the parts tripled. So 2x times 3, 3y times 3, and 43 times 3. So every single part of this got scaled up by 3. And we could double the other one. So we doubled this one, and we get, so 3x becomes 6x, 2y becomes 4y, and 47 becomes 94. And now we have matching coefficients for x. And if we subtract the same thing from the same thing, it goes away. It becomes doodly squat. It becomes 0. So we can subtract these equations. We only add if we have opposites, by the way, if we're trying to eliminate. And we are trying to eliminate. We're going to eliminate a variable. If we subtract 6x from 6x, we eliminate the x variable, making it 0x. Okay, and then if we subtract 9y minus 4y, we get 5y. And over here, if we subtract 94 from 129, we're going to get, let's see, 9 minus 4 is 5, and 12 minus 9 is 3, so we get 35. And so you've got, I'm going to do this right underneath it. It's really useful to organize your work vertically because it's easy to see if you make a mistake. And then you can go back and track it and figure out where it is. Organizing your work instead of going all over the page really helps. Okay, so I'm going to divide both sides by 5 since both sides are 5 times too big. And I get y equals $7 per propeller beanie. Cool. That was one of the coordinates for our solution. Now we can do the same thing to get the y coefficients to match. We'll be able to get the y coefficients to match since the least common multiple of 3 and 2 is 6. If we double this equation, so double this, sorry, hang on. Actually, I'm doubling so I've double this equation. Now you may notice I rearranged the order here. So we double it, I get 4x instead of 2x, 6y instead of 3y, and 86 instead of 43. And then if I triple the other equation, I get 9x plus 6y equals 141. So now I've got this equation, 9x plus 6y equals 141, and 4x plus 6y equals 86. And now I can subtract the equations from each other to get rid of the 6y. Now I have choices about which way I subtract. It doesn't matter, honestly, whether I subtract 4x plus 6y equals 86 from 9x plus 6y equals 141, or if I do it the other way around, I could flip that. Either way, I'm getting rid of 6y. So I will have eliminated the y variable, and I'll be down just to one x variable. I chose to stack it this way because it means I won't have to deal with negatives. I can deal with negatives, but if I can avoid it, I sometimes will. So my first thing, I can subtract 9x minus 4x, and I get 5x. And then notice that 5 keeps showing up. And then 6y minus 6y is 0y. And then 141 minus 86. Okay, let's see. 1 minus 6, we're going to borrow from the 4, so that's an 11. 11 minus 6 is 5. And then I've got a 13 because I borrowed from the 4. So 13 minus 8, really 130 minus 80 is going to be 50, so 55. So I've got 5x. I don't care about 0y. That equals 55. I will divide both sides by 5. And now I just have x equals 11, because 55 divided by 5 is 11. $11 per pointy hat. And now I know the price of pointy hats and propeller beanies through the system of equations tool called elimination. So we use the tool of graphing here. We graphed, and then we subtracted the equations. Since we could rearrange the equations so we had matching coefficients, we subtracted the equations, doing it either way, and we got rid of a variable, eliminating it. And we now have the prices another way. So those are two of the three main systems that we're working with right now. Here are, of course, actual advertisements from the 1950s for propeller beanies. I hope this has been helpful.